chemistry students. So today we're going to be starting a new topic called oxidation and reduction. And we're going to start with a demonstration about this stuff. This is solid zinc. It's just your standard transition element, but we're going to write it a little bit differently than we have in the past. This is zinc, but when we're talking about this kind of zinc, just solid zinc, we're going to put a little zero here because this isn't a zinc ion. This is just the atom. It doesn't have any charge associated with it. But we're going to mix that with something that has become ions. We're going to mix it with this solution, which is tin 2 chloride. And if you remember from naming, if there's a number in the name, then that tells you what the oxidation number is. So this is tin with a little +2 charge, chlorine. So that's the chemical formula for tin chloride. Now if you look at this, tin is +2, you need 2 Cl's, so these must be -1. And that's what we're going to be doing in this topic, making sure we have correct oxidation numbers, because in oxidation reduction, one of the metals is going to be oxidized and one of the metals is going to be reduced. You might be familiar with the word oxidation. That's rusting, but sometimes it happens faster, sometimes it happens slower, and it doesn't always, just turn orange like you would think of with rust. So here we have zinc is going to react with tin chloride, and what's going to happen is they're going to switch partners. It's a single replacement reaction, so you're going to end up with zinc chloride and tin. So if you look at this, 2 Cl's, yep, that's going to be balanced. But all of a sudden, this zinc now has a partner. If this is -1, then this zinc has become +2. And if this tin is all by itself, it's no longer an ion. It is now 0, because anything by itself has a charge of 0. And this is where we're going to start to talk about how does that happen? How does a 0 become a +2? Well, how does something become a charge? It's because it loses some electrons. So we have zinc that has no charge, and it becomes zinc +2 because it shoots electrons out from within inside of it. There's this thing called conservation of charge where 2 electrons are going to have to come off of this atom of zinc so that the thing can become +2. You ready to watch some electrons shoot out? Here we go. We're going to take our zinc and we're going to get a smaller one so it's under the solution, and we're going to put it into our tin. Bam! And look at that. Wow. That's amazing. Camera effects. And you think, why isn't there, electricity shooting out the sides? Maybe there is, you just can't, there's bubbles, but I don't really see, it's really blurry actually. I don't see any electrons shooting out of this thing. What's going on? I mean, kind of looks alive. It's doing something. What's actually happening in there is not only is the zinc giving off electrons, but if you notice our tin also changes. It changes from +2 to tin that's 0. And the only way something can go from +2 to 0 is if it actually takes in negative things. So those 2 electrons aren't shooting off into the world, aren't shooting sparks out into the universe. No, those electrons are leaving the zinc and they're going into the little tin ions. Therefore, the tin is going to actually come out of solution. So if you look closely, you should be able to see, after a little bit of time passes, the zinc no longer looks like zinc. Instead, it's got this coat on it of tin. And if we let it sit long enough, it'll actually kind of look sponge-like. Join us on Thursday when we talk about oxidation reduction reactions. And if you'd like credit for this week's watching videos, tell me something that oxidizes besides iron, or in this case, zinc. Give me an example of something else that you've seen oxidize.